In this lesson, we will learn about the various features of Azure Kubernetes services. AKS is flexible as far as deployment is concerned. So you got number of deployment options. You can deploy an AKS service with portal, command line, and even with a ARM template that could be written with JSON or with Terraform. When deploying an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. When you write that ARM template, you can also write several detailed settings as far as networking is concerned, or if you'd like to integrate with Azure Active Directory, or maybe write some monitoring metrics into it so you can configure it during the deployment process. The AKS clusters also support role-based access controls, and that means that the AKS cluster can be configured to integrate with Azure Active Directory. In this configuration, Kubernetes access can be configured based on Azure AD identity and also based on group membership. The container health gives you performance visibility by collecting memory and processor metrics from containers, nodes, and also from Kubernetes controllers. Container logs are also collected, and that data is stored in your log analytics workspace. You can then take a look at the workspace using the portal, CLI, or using APIs. As the demand for resources increase, the nodes of the AKS cluster can be scaled out to match the demand. If the resource demand drops, nodes can be removed by scaling in the cluster. AKS scale operations can be completed using the Azure portal or also using the Azure CLI. Azure Kubernetes Services offers multiple Kubernetes versions. So as new versions become available for you, your cluster can be upgraded using the portal or from CLI. During the upgrade process, nodes are carefully managed and drained to minimize disruption to running applications. The HTTP application routing solution makes it easy to access applications deployed in your AKS cluster. That means when you enable the HTTP application routing, it will configure an ingress controller in your AKS cluster. So as the applications are deployed, publicly accessible DNS names are automatically configured. For applications that need lots of graphics, AKS supports the creation of GPU-enabled node pools. Azure currently provides single or multiple GPU-enabled virtual machines. GPU-enabled virtual machines are designed for compute-intensive, graphics-intensive, and visualization workloads. There are a lot of tools that we have in today's world as far as development is concerned. Kubernetes has a rich ecosystem of development and management tools. So think about Helm, Draft, or the Kubernetes extension for Visual Studio Code. These tools work seamlessly with Azure Kubernetes services. There's another service called as Azure Dev Spaces. You can use that and it will provide a rapid, iterative Kubernetes development experience for your teams. With minimal configuration, you can run and debug containers directly in AKS. An AKS cluster can be deployed into an existing VNet. In this configuration, every pod in the cluster is assigned an IP address in the VNet, and that can then directly communicate with other pods in the cluster and also with other nodes in the VNet. Keep in mind that these pods can connect to other services in a peered VNet and also to on-premise networks over ExpressRoute and site-to-site VPN connections. We all know about the container registry by now, so the AKS clusters can integrate with the Azure Container Registry for a private storage of your Docker images. Let's understand more about Azure Kubernetes services by learning about clusters, master nodes that are Azure managed, and the customer managed nodes as well that will be actually running your application workloads. Let's do that in the next lesson.